Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are back after taking a break. We took a break post Handmade Con. And we did a couple streams during that time. We did some streams on people switching careers from whatever their current career was to a career in software development, and we had a bunch of really cool stories people wrote in, so we read those. So definitely check that out if you haven't seen that already. It's kind of an interesting not side project, but I guess side stream to Handmade Hero, sort of like additional information. And I kind of been doing some stuff like that just in general, as because one of the things that I talked about in those streams specifically was just the fact that a lot of times on Handmade Hero I get asked questions that I don't know the answers to. Not technical questions, but like personal questions, like, what would you recommend if I'm trying to switch careers to software development, or what should I learn if I'm going to start doing game development, and these sorts of things. And a lot of times it's like, well, I haven't necessarily been through the kind of circumstances that other people have. I started programming at a very early age, so I don't know what it's like to come at it later on in life and decide that you want to make a switch to it, those sorts of things. So I find it really helped doing this past series of streams. I found it really helped to just like ask people, because there's a lot of people out there who now follow the show, which is awesome, and they're willing to tell us their stories about what happened to them when they did go through those different paths in life towards getting to being a software developer as their primary career. And so I'm kind of interested in doing some more of those, just further down the line whenever we take a break or whatever, maybe in the interim during those breaks or whatever, just asking people to write in and seeing if we do get, anytime we get a good collection of stories, just kind of doing a thing where we read them, because I think it's pretty handy, and it just kind of gives a broader perspective on things than I can give by myself, because I don't really have any experiences to draw upon other than my own, which are, I think, actually relatively unusual, right? Like I don't know that there's that many people who started programming as early as I did, and who really haven't explored any other career options. It's not necessarily the common case for software development, so it doesn't necessarily provide a lot of utility to people who are coming at it later than that. Even if it's something as late as doing it in high school, it's still pretty early by most standards, but was much later than I ever considered getting into it. So I really just don't have much knowledge of that. I don't really have the personal experience to draw from to sort of say like, oh, this is what it was like, and this is what was hard, this is what was easy, because what's hard to a 7-year-old is very different than what's hard to a 15-year-old potentially, which is much different perhaps than what's different for a 30-year-old, right? Because their life circumstances have changed quite a bit, and their existing knowledge base and what they've already sort of grown to do habitually in life and these sorts of things change very dramatically over those, sort of parts of your life. So anyway, I'd like to get back to programming now. We're here on day 352. And I believe, hopefully, our to-do list is still a pretty good guide in terms of what we want to do. And I believe we're just sort of tying things up. We really don't have much to do in terms of game engine stuff anymore. Like, I feel like we've taken a reasonable amount of time to go through and just sort of demonstrate how to look at a game engine, all the different parts of it, and we've sort of done everything that you might think you might want to have in a game engine in terms of like at least one example of how that thing might be done. And so we were just looking at finishing up this multiple sim regions per frame stuff. And the multiple sim regions per frame stuff is just a way of us trying to figure out, can we leverage multiple processors in the machine to simulate different places in the game separately, right? And there's a couple different things that was important for us to sort of figure out how to do there, and we're sort of working through those. So just continuing down that path a little bit, just to do some stuff like clean up the camera usage and that sort of thing. On the other hand, after that, I think, and it's still, I guess, a little bit of a question, but I'm pretty sure that I would like to do it. I might want to rewrite one thing that we've done, which is that we did our renderer in 2D, And I'm kind of glad we did that because I've never done really a 2D renderer before for the most part. Like, it's just not something that I've experienced with. I've always really done 3D, even, you know, very early on in my sort of programming. I think even as early as, you know, when a little before, like maybe junior high school, I think, was probably the last time I ever really did much in the way of 2D engine work, to be honest. And so, you know, I had never really done a 2D engine, and so I just don't love it. Like, I feel like there's just too much in it that's sort of not flowing through a nice uniform pipeline. There's just too many special cases for things, and I don't really like it. So I think I would prefer to sort of upgrade our graphics to sort of 3D. Now, that doesn't really mean we're going to pull in any 3D assets, but I'm basically just talking about, hey, instead of rendering tiles, maybe I'll render like little cubes, you know, more like a Minecraft sort of style where the textures are on the sides of the cubes or on the front of the cubes or whatever. So when you have like raised pieces, it's actually like a little 3D thing. And then the actual characters are actual Z-buffered stand-up, you know, cards. And the reason I want to do that is just because although the Z-buffer is something that you don't necessarily want to use if you can avoid it, because obviously, well, it costs bandwidth for one thing, but primary reason being that that you can't necessarily do as much with transparency and stuff like this if you count on the Z-buffer to resolve your depth problems for you without sorting. Those are pretty minor concerns compared to all of the stuff that we had to do to sort of make sorting work reasonably. And I really just didn't like that. I feel like it just creates an ugly engine that with a lot of sort of pitfalls in it. And so I would like to make that transition before we move on to just writing regular game code where we're not really thinking about the engine particularly much anymore, and we're just working on things like how do enemies behave and how do we want rooms to be generated and that sort of stuff. So that is, I think, what we want to get to is just this little breakpoint here, and then we'll do this thing and do a sort of 3D graphics upgrade and just kind of move our stuff over to that. And then collision detection, I'm not actually sure how much we actually need. We already implemented the main kind that we wanted, which is the fact that people can't stand on squares that are occupied, and that's done. So the other kind really is just for probably mostly projectiles, things hitting other things like that. And so now that we know exactly what we need that for, just going through those routines and cleaning them up and doing like solid implementations of them. Because I put in one a long time ago that was a really basic implementation that is not one that we want to ship, but that's still in there. Just moving that out and making it a little bit more reasonable is all I'm really talking about. So that's it. AI storage is probably not something that we can really tackle at the moment. And the reason for that is in order to have something like AI storage, we have to have some notion of an AI who wants to remember things from frame to frame. Meaning right now we pretty much only have enemies who do their planning in a fairly local sense and who don't store particularly much information. We don't have, for example, an enemy which needs to store complex world knowledge or something like this. I don't know that we really need to ever have anything like that. It's kind of on the to-do list here just because it was sort of a thought of like, well, we haven't developed anything for that tech. Should we need something like that? But I don't really have anything in mind that would require anything particularly complicated here. You know, I guess the thing that I would say is, like, even something like pathfinding, I don't know that we really need anything in particular with storage. We can probably just, in the entities themselves, store a few steps of path if we want that sort of thing. So I don't know. So I'm going to just basically say that that probably isn't going to happen until we actually need it, if we need it, because I don't think it's particularly relevant at all. So I think, yeah, like I said, really what we want to do here is just focus on finishing up the multiple sim regions per frame. I think that's the last thing that we were looking at before we could basically say, like, all right, not really anything else to do here. So let's go ahead and do the 3D upgrade, and we'll just do the graphics and collision for 3D and call it a day, engine-wise. And really that would mostly be, it's not a huge deal to upgrade something from 2D to 3D. It's mostly just going to be sort of me having to explain a few things that we did not cover in much detail because we didn't actually need to. We tend to think of things mostly as screen space. We haven't introduced anything like clip space, for example. So there's some things about a 3D pipeline that we kind of need to talk about, but otherwise there really isn't much we have to do in practice other than sort of make more rigorous our ideas about where things are in 3D and how we're going to deal with them, because we already have a backend that supports OpenGL and stuff like this. So moving that over to just using regular 3D is simply a question of working out the math a little more carefully and showing like how that sort of stuff works. There isn't like a whole re-architecting that has to happen or anything like that. Plus, we're already sending stuff down to our renderer in 3 dimensions. We already provide 3D positions for things. And so really, all we need to do there is just, instead of pre-processing that into 2D rectangles that are in screen space, which is kind of what we're doing now, we're just going to leave that data untouched and pass it down more directly. And that's really all we're talking about here. So again, not really that complicated what we're talking about. It's not really a big deal. So I'm not anticipating that to be a huge thing in terms of actual stuff we need to do, but it is a rather big deal in terms of us kind of trying to teach a bunch of stuff that is not necessarily important when you only have 2D. So it will take a while to do because we're going to have to take it fairly slowly, and I'm going to have to go through a bunch of concepts that we don't really have to visit in the 2D sense. But other than that, it'd be pretty straightforward, I think. OK. So let's remind ourselves where we are here. Pretty much, like I said, everything I think is still kind of very straightforward, right? Where everything's still running OK. And our kind of weird AI is jumping around, and our weird like head-based particles. I'm gonna have to ask Anna what she wants for particles. I'm assuming she'll want some particle sprites, but yeah, basically there's not really that much in terms of stuff that we don't have, as we kind of talked about before. We're pretty good to go on engine stuff. So I think the only thing we really want to do is finish up the multiple sim reads and stuff, and then we'll go ahead and deal with our 3D changes. Now, one of the interesting things too here is that I'm pretty pleased with how everything's working as well. You know, like I said, we've got some stuff that's not as good as you know, maybe we would want it to be. But one thing that is pretty nice is, you know, we already handle all the stuff we kind of wanted to handle, and it worked out pretty well, at least so far. Now, we haven't, you know, shipped anything yet. So it's, you know, it's too early to declare victory on anything, certainly. But our design seems to be holding up relatively well. You know, this world can be arbitrarily big. We tried just slapping down tons of rooms, and we don't suffer really any performance penalties, right? We still run at 60 frames a second. Everything's fine. Even though we can simulate as much of the world right now as we kind of want to, and we successfully, we don't suffer from any floating point precision, none of these things. So all the stuff that we kind of wanted, as far as I know, we've pretty much got, right? So we can literally create worlds that would be extraordinarily large here. I could walk through all of them, and none of it's a problem. And again, we also can simulate as much of it as we want to at the moment. And, you know, and the parts that we don't want to simulate don't have to be simulated, and it doesn't create any issues, et cetera, et cetera. So all that stuff seems pretty good, and I'm relatively happy with it. But like I said, the 2D-ness part of it, I'm not particularly psyched about. So yeah. Anyway, so that's really all there is to that. I'm going to go ahead here and exit out of here. In terms of the simulation region stuff, it's going to take us a little bit, since we haven't programmed in a while, to kind of get back into it. But if you remember what we were doing before, in world mode here, you can kind of see where we've got simulation happening. You can see where we're playing around with this, right? here is the actual primary region of the game where the player is standing. This is where we do the work that we actually want to do for the game you see. But up here we had an example of what happens when you want to do simulation for the part of the game that you can't see. And here we basically like farm off a bunch of threads, which all those threads can go and do actual simulation of different parts of the game. So what that looks like, right, is right now other parts of the world are being simulated. If we take a look at the profile, you can kind of see that happening here. I'll go ahead and pause the profile on a frame here. And you can kind of see that we've got world simulation happening on a number of threads, right? So that is really just to allow us the opportunity to take advantage of multiprocessor machines to simulate more of the game world than we could if we were only simulating one on one core of the machine. Now, we don't really need this yet, obviously, so it's just sort of a test to make sure that the technology would hold up okay, if that's something that we wanted to do. But, you know, like I said, it was good to just figure out, like, would we be able to do that with our architecture? And the answer appears to be yes. Now, what I wrote down in terms of to-dos for that is, well, okay, you know, we have a number of things about the sim that we tried to clean up the fact that they're running a multiple. We tried to kind of isolate what we were going to do with the simulation, and you can see here in do world sim exactly what needs to get done. It creates a memory arena. It does a begin sim step, which is like preparing to do simulation. It does a simulate step, which does the actual simulation, and it does an end sim, which sort of finishes this up, and then it like frees the memory it was going to be using. One of the things that we wanted to do was not do this anymore. We wanted to sort of have arenas that were set up specifically for work on multiple threads. So that is something we definitely want to look at in a second. And then the other thing is here in update and render world, you can see why we broke it down that way. We have this concept of the begin sim again, but then there's other stuff that we might want to do, like check for joining players, and then we do simulate, right? And then we do end sim all the way at the end. And while the simulation is open, we also draw some things that we care about and do things like taking the camera deltas and that sort of stuff, right? And so, you know, what we tried to do here is basically make that simulation stuff work so that we could do it in both cases and use the same code in both cases. One of the cases is we're just going to go ahead and simulate the game part that you actually see. And the other case is we're trying to simulate something where it's off screen, so we don't care about the camera. We don't care about drawing any additional things like at all. We don't care about checking for joining players because they wouldn't be joining in those regions. They'd be joining in the region we could see, et cetera, et cetera. So that's what we did, and that was all relatively good. But there's still some stuff in there, like, so for example, if we take a look at what happens here in end world change, which is a big part of NSIM, right? If we take a look here at NSIM, you can see that mostly what NSIM is just finishing the use of the temporary memory for whatever that temporary memory is, and calling in world change. Oh, excuse me. Tired boy. All right. So end world change, when it comes through here, a lot of the work that it does is checking this, you know, camera following entity index situation, right? And what that does is that's just a thing which updates the camera in the case where the entity that the camera is supposed to track is in this simulation region. And so the sort of the aspects of that I'm interested in here is saying, well, I don't really love that because I don't really feel like that's appropriate thing to be stuck in the middle of this multi-platform simulation stuff necessarily. It's kind of hard to say. So I'm not sure that we want that happening all the time in here. Now, maybe we do, maybe we don't. It's kind of hard to say. But if you see how this goes, in fact, let me go ahead and just demonstrate this. if you see how this goes, it creates an entirely weird dependency here on the sim region stuff that really wouldn't have existed for any other reason. We have to reach into the world mode structure and deal with this camera following entity index bit here. But the only reason that we have to do that is because we're updating the camera right here in line. And so it creates this weird sort of knowledge in the sim region of the whole game world situation for no reason other than it needs to have this camera following entity index. And so, you know, is there anything wrong with that? Not necessarily. But it does mean that I've sort of created a dependency that I wouldn't ordinarily have. And you can see here, when we do begin world change, we do not need any of that, right? We only care about the actual world struct, the thing that actually stores the data for the world, which makes sense because that's what we're operating on. But, you know, our ending world change is not symmetric. You know, it should look like that because it's just ending the simulation of this world region. But instead, it takes this because of that sort of ancillary camera aspect. So what I'm kind of interested in here is, like, can this be pulled out as well into a special purpose thing that's only there for people who care about the camera and isn't there for people who don't care about the camera, so that it's not sort of creating this artificial dependency between these two systems that really isn't quite there, if you will. And, you know, again, why do I care about that? And mainly the reason I care about that is that, in general, I like to try and separate out things which are really dependent and things which are not really dependent. And the reason for that is that it just makes code simpler to maintain over time, right? In a circumstance where everything talks to everything, right, where all of my routines are grabbing stuff from everywhere, it makes it very hard to isolate a particular piece of the code and say, here's exactly what this does, and here's exactly what it needs to function, right? It makes it harder to continue to do that. Because I never really know what other things, you know, it's too hard to keep that all in your head potentially at once, what parts are dependent on other parts. So reducing those dependencies is just a helpful tool. When you see a dependency like this one that really doesn't need to be there, removing it is usually a good thing to consider for that reason. This is very much like, again, sort of the functional programming style of looking at things, just to a lesser degree, right? It's saying, you know, functional programming is about saying there are no side effects, and I pass in everything that I need to operate on explicitly, and so on and so forth, right? And, you know, if you want to take it to the nth degree, you would say, well, I'm going to pass in literally everything by value, right? Like I'm going to enumerate absolutely everything this thing needs and take as return everything that it possibly could touch. You know, taking that to the nth degree is you know, maybe the purest functional programming you could imagine doing or something. I don't really need to do that, but I do believe in minimizing dependencies and side effects where possible, because again, it just makes it easier to think about the program. You know, it's a purely functional program is very easy to reason about because it just doesn't have very much you have to look at. You can see from the function signature in a purely functional program exactly what a function needs and what it does, right? And that's very handy. By contrast, in something that does a lot of side effects, it's very hard to understand necessarily all of the things that it touches. That's also what makes it powerful, and it's why side effect-based programming is the kind of programming that almost everything is at some level. But again, just because you need to do that to be an effective programmer doesn't mean you don't also want to appreciate what you're sort of giving up for that freedom and ability. And that is sort of that understanding of exactly what a function actually touches and what it could do. So in this case, that's why I've sort of singled this parameter out here as something that I'm like, well, I don't really believe that this routine needs access to that, and I would rather have a version of the routine that didn't do it. So the question is, how do I, you know, like if I was going to pull this out, let's just see, what does that actually look like, right? Let's go ahead and get this here. So here I've pulled it out. Oops. Got to get my key bindings. I forgot I changed my key bindings one of my key bindings for Coder. It was only one of them, but I changed it on my dev machine. I forgot to move it over here. So if you look at what happens here, this is where camera code used to happen here. So we'll just put that in for a second. So you can see what happens here, right? We used to do this mapping, the map into chunk space bit, and then we would do some stuff with the movement of the entity, and then we would update the camera code, and then we would sort of retire that information back into the world data structure. And this is the place where eventually we would sort of pack the data for the entity, but we're not doing that at the moment because, again, we don't have any need to do that up until like more towards the end of development, when we're more cared about space and speed and so on. So that's all that is. But now we could look up here and say, okay, so if somebody wanted to do this part of the process, right, what do they actually need? So let's take a look and see, what if I was to make this a function that was just, update camera or something like that for, entity movement or something like this, right? So if I was going to do that, the question now becomes, all right, so if I was going to update the camera for entity movement here, what would I want to do if I was passing this stuff in? So, I've got an entity structure, right? Obviously, that's going to work. Let's take a look at what our other compiler errors are. What do we actually need here? So we've got the world mode. All right, fine. We'll pass the world mode in for the moment. Is it game mode world, I think? Yeah. And then we also need the world. And we need the entity P. All right. So let's take a look here. We're looking at the room-based camera. That's the only one we actually want, right? So if we're taking a look at what would happen here, maybe we just say, well, this is the part we actually care about. We don't do the other kind of camera anymore. So if I want that, what do I get, right? And it looks like, just from doing that, it looks like this function is essentially totally isolatable, right? So that's actually perfect. I want to look at what the world's actually used for here, because it says it wants the worlds. What's going on there? Oh, that was just to test something. Where is that used? Okay, so we need map into chunk space to figure out what we're doing with the camera there. So that's why we need that. So if we were going to update the camera for entity movement, it would look something like this. Okay. But now, like I said, we've sort of pulled that out. We're still in debug build, right? Build out that. No. Here we go. OK. So we've pulled that out, right? But now if we ran, our camera wouldn't function anymore because we're never calling it, right? That thing never gets called by anybody, right? So if I come through here and we'll do whatever we're doing, I can walk off the screen and not good, right? Not great. So at that point, the question is, who calls this and why, right? And when? So we don't probably need to do this anymore, where we say like entity ID value, world mode, camera following entity index, any of that stuff, right? All I really need to do, because I can access entities, is I just need to make sure that when I pass this, I'm only passing the entity that I actually care about here. And in fact, in some sense, we could pull out the world mode camera stuff into its own thing. We won't do that at the moment, but anyway. So really what I can do here is just say, hey, you're only going to call this thing with the entity that you're actually following. And so, excuse me. And so we can just assert that no one's trying to do that with any other entity for the moment, right? And later on, we may want to do stuff where we change how that works or something, but for the moment, we'll do it this way. So if we were going to do update camera for entity movement, we'd pass in the entity that is the one that matches the camera following entity index, but we need to do that somewhere, right? And so if I go into the world mode itself here, and I take a look at where we're doing the main update, this is sort of where we would want to do that that stuff. It would normally, I guess, happen right here. because this is where, this is before the endsim would happen, right? And so if I was going to do that, I could just call update camera for entity movement, and I could pass the world in the world mode. And the only thing I would need here is the camera entity, right? And I don't know what that entity is. So the question is, where do I get that entity from? Well, in the sim region stuff, we should be able to access an entity by its ID, because we already have to do that for a bunch of reasons, right? So we've got a function right here that will use the hash table in the sim region for this very purpose. So we should be able to just call that here and get an entity by the ID, which we know because it's from the world mode, the camera, right? That's exactly what it's from. So here's my begin sim, right? And I'm going to get back the world sim. The world sim has the sim region in it, so I know that inside here I can just access that. And then the only question is, well, where is that, what's the entity ID that I need? Well, that was exactly the thing that we were just talking about here. We actually store whatever that entity index is. We store that in the world mode. That's the entity that we're following with the camera at the time. So if I just pass those two in, it should give me back the camera entity, right? And I assume I can also say, well, OK, if there is no camera entity, don't try to update it. But presumably there always is for the most part, right? All right. So now, in theory, I should be able to follow my little hero friend here. He should be able to hop out of the room. There we go. There we go. And we've basically just restored that functionality. But now that routine doesn't actually have any problem with being coupled sort of to the ending of the simulation. So that's good now. That's out of there. And I like that better because now we can see more concisely sort of what's happening with the begin world change and end world change. I might go ahead as well and just say, let's move those two functions next to each other. Here's begin world change, right? And here's end world change. And that way I can sort of also just see them, right? Looks like that may be easier said than done. This can certainly move out of there, though. There we go. And let's see, create entity, delete entity, pack entity reference. Create entity and delete entity certainly don't need to be there. Those can go outside as well, I think. There we go. And so really it's just those other two packing things that will intercede. So anyway, I think that's it for that. And I could put these above it as well. I could say those go right here. And then we can just see relatively easily those two routines. Here's the begin world change one, which is getting relatively respectable. And then there's the end world change one, which is also getting relatively respectable. And so it's got the pack and the unpack there. And the pack and unpack, again, will then become more of a real thing, far further down the line once the game's already, more complete. The game part of the game, not the engine. So that's it. OK. So if I take a look at pulling out the camera concept into something clear and optional, I think that's really all I need to do right now. We could take it one step further. I don't know if we want to. And that step further is inside the game mode thing here. You can kind of see we've got camera offset, camera P, last camera P, camera following entity index. Those things could be put into a camera structure. So for example, we could say something like this, which would essentially be, oops, that sort of thing. And then what would happen is anytime we were working on something like this, where we were previously talking about the world mode, we would not necessarily use the world mode anymore. So if we take a look at what happens with world mode here, you can see that almost in every case, we're talking about the actual camera stuff. So the only place we're using the world mode as the world mode is by looking at the room delta. And the room delta is really sort of more of a property of where you are in the world at that point. So that probably should be more of a query on the world, not on the world mode anyway. But anyway, so if you take a look at what happens in there, if I just scan through sort of what's happening here, you can kind of see that in a lot of cases, when we're updating this, it would just be like adding an extra dot in here. So let's go ahead and do that since I took that step anyway, or just I'm showing how to do that step. Let's just change this to last P and P and offset and following entity index, and then we'll go ahead and switch on here. So if I just do something like this, right, you see how that's changing. All I'm really doing is changing it to a dot in all of these cases. Nothing particularly exciting here, like that. Right, and then again, same thing. Let's take a look at this. So that would just be, this one kind of inverts itself a little bit. That's camera last P. There's camera P. Almost done. Again, just a mechanical transform here, just literally pushing it down one level first. There's our camera P again. And camera.offset. Let's take a look at this here. There's, go. And almost done. Okay. So at that point, again, now all we've done is just kind of move code into a different place. We should get rid of, I'm kind of tired of those weird teleport regions which we were playing with before. Let's go ahead and stop that poor fellow from bouncing around so much. There we go. Where were those things? Were they on here? Or I don't remember. Yeah, there we go. So it's this weird like target ref situation here. Target ref. That's the one. So this thing, get rid of the auto boost. Now everyone should be a little bit more sane. So anyway, now we should have, again, exactly the same functionality we had before, which is all we were really looking for. And so that's all fine. And so now what I can do is I can also say, well, okay, now some of these things that were taking the camera before, let's just take a look at where they all were. And again, one of the ways that I like to do that a lot of times is just kind of go in and say, well, if everyone was accessing this camera previously, I'm just going to go ahead and get rid of that there. And now I can see everywhere where people were talking about the camera. So obviously, update camera for entity movement, because the compiler will error out now all the time when anyone tried to access it. And so if we take a look here, what happened when we do update camera for entity movement, really this is all talking about the camera. So if I just said game camera camera, I wouldn't need the world mode anymore, except for one very specific circumstance, right? So I could go ahead in here and just say, like, okay, everywhere in here where we were accessing this off the world mode, I'm just going to access the camera directly now, right? And that's kind of handy because now, and I guess I need to, there we go. Fatal error. Wow, all right. Wasn't expecting you to fatal error on this. Because the only thing we need the world mode for, I guess I should go ahead and change these as well to camera arrow, since instead of camera dot, those will all be arrows once the compiler figures out it isn't really that fatal. Okay. So the only thing we need the world mode for is that typical floor height, which again, I think is probably more of a property of the world, if anything. I think that's something we're going to want to upgrade anyway in the world structs and so on. But if we were to take a look at the world here, where we're looking at this. I'm just going to put that in here as like typical floor height into the world so that we can just kind of access it there, right? So let's take a look as well at, in fact, typical floor height is really just the chunk dim in meters Z, if I remember correctly. Like, I'm pretty sure, actually, we could just do it where we were saying, hey, the room delta is, you know, a particular size or whatever. But what I'm kind of interested in here as well is looking at this as a non-relative phenomenon. So I'm gonna kind of hand wave that here for a second and just say, like, okay, it is whatever it is. Let's go see what, let's see here, world mode. Let's see what typical floor height actually is. It's 3. Here we go. And now I think, let me look at if any of these are other ones that I want to look at. No. No, all that's fine. So all that's pretty much fine. All right. So in here, yeah, when we are talking about the camera, I'm just going to pass that in here. So world mode camera. I'm going to pass that in. We'll change the world mode camera to this, and off we go. When we do the update camera entity for camera movement, I want to push that camera first since that's the thing being operated on there. And there we go. All right. So what I wanted to say about this room delta stuff is one of the things that I definitely don't like about how we're doing this at the moment, now that we're sort of in the camera world, and I think when we move to 3D, this would be also a very good time to think about that, is if we wanted to have multiple size rooms in the game, right? So imagine wanting to sort of have maybe a double length room or something, like, you know, that was twice as wide or high as another room, and you wanted the game to pull out so it kind of like the camera went up higher and showed you more of the world when you were in that room. That's a pretty reasonable thing to want to do, right? You know, there's nothing in the engine that would really prevent us from doing that, but right now we kind of have this hard-coded notion that the rooms are the size that they are as far as the camera is concerned, so that becomes sort of problematic. And so I think what we need, kind of going forward, is the ability here to say, well, where am I in the world? What room am I looking at? Because I feel like a room as a concept kind of needs to be baked in now, where a room is, you know, it doesn't affect any entity stuff or anything like that, but it would need to just sort of be a nice little, it would have to be something that just sort of said, hey, here is like a bounding box that says this is a room as far as this area of the world is concerned, and this is the room you're in at the moment, right? And if we look at how room delta works here, we wouldn't really need to do any of this stuff the way that we're doing it either. What we could do instead is just say, when we have decided we're moving from one room to another, or whatever room the hero is in, we can just say, oh, well, whatever room the hero is in, let's move the camera towards that position, right? And that's a sort of a you know, much more sort of straightforward thing that we might want to do there, right? Hopefully. All right, so, you know, that's a thing I think we want to probably get to, and maybe we'll do that with the 3D thing. I'll put that in the to-do here. Let's take a look. So we'll call that 3D, you know, So something like that, basically. Okay. So now we've got our, now we've got our fairly basic stuff happening where we're doing our simulation work, and we have pulled out almost everything from it that we don't think needs to be there. And so let's see here. We've got the camera stuff pulled out. This stuff, I think, again, like I'm pushing down a little bit. And we did exactly this. We eliminated world mode from the sim step entirely there. Although, well, that's not actually true. So we still have in simulate, that still happens. So we're not quite done with that yet. We're not quite there yet. So let's take a look at what's happening in simulate there for the world mode. So let's see. We're in the sim region. Where is our simulate call? Let's see. So right now what we're doing is we're doing brains, and let's see, typical floor heights being passed through here. The typical floor height gets passed around a lot, to say the least. All right, so anyway, let's take a look at when world mode gets passed. It looks like world mode isn't really used for very much at the moment, actually. That's interesting. So really, it's just the entropy and the floor height. That's all that it's used for, and then it would be gone entirely. That's pretty great, actually. All right. Well, let's go ahead and finish that up then. It's further along than I thought it was. To say the least. So we're getting there. It's good news. All right, so let's get rid of that. And now we can basically just say, like, okay. All that stuff goes away. Okay. So looking at world mode now, it also looks like, okay, so let's see. Simulate's taking it. Let's keep pushing this a little bit further, right? Because here you can see a fairly concise version of this. Yeah. So let's take a little bit closer look at this. And let's see. Can I go to world? It's just world. So let's take a look and see if we can't push that a little bit further, because it looks like it's almost there, actually, at the moment. So I'm going to come in here to sim region. I want to take a look at begin sim, begin world change. And I just want to see, so that doesn't take the world mode yet at all, so that's good. And if I look at begin world change, if I look at begin sim, what does that actually need the world mode for? Yeah, so that's really, it's really just for updating the camera, or rather looking at the delta, the camera delta that needs to happen there. I'm kind of interested as to why that's still happening where it's happening, right? Like why that's happening inside begin sim. Because again, that's really not something that probably needs to be happening there. Like I don't know that the camera P needs to be computed there anymore, right? Because if we take a look at world mode here, and we look at where we're actually using that, let's take a look. And we say, okay, simulate world mode camera. Let's see, and do sim here. Camera P is just not used, right? So it's only the case where we actually care about it. We only care about that case in here, right? So I think that's probably something where that's actually not what we want to be doing. Yeah, pretty much at all, right? So when we call do world sim here, and we call begin sim it's just using the world mode to get that camera for no reason. So yeah, I can verify that that's just, yeah, again, this is exactly why I want to go through and remove these dependencies, is because, you know, there's a lot of stuff in here that just doesn't really need to be happening in most of the paths, right? So I think this circumstance is really, you know, this stuff really only wants to happen on this path. Pretty much the only time that wants to happen, right? So world mode camera P, in this case, that stuff wants to happen in here as the way that it would tell it how it was going to do, you know, like essentially where the simulation was going to take place, if you will, would be passed in like this. And then in the case where you were actually updating that camera P, it would come in here where you do the subtraction at the end of things, right? I think that's how you would want to do it. And so whatever that previous sim center was, that would be, I guess, coming in here. Let's take a look at that. So here's the sim center. I'm not sure it's still just the same. It's not even going to get updated by that. So really, it's just saying, I'm not even sure, because these two are the same value, right? I mean, am I missing something here? Because the sim center, let me just verify to myself that I'm not delusional about that, because it sure does seem that way. So we take a look here. We say, here's the sim center P, right? It's the same as the camera P. So in this case, we're going to do that subtraction there. Well, that subtraction is, we now know, completely useless, right? Anything that's going to be an offset is going to be in here. So essentially, it's just that. Right? Nothing needs to happen. And presumably, that's it, right? So if I wanted to, I could just start using the camera here exactly this way and, you know, go out of here, and it still works, right? And I don't think there's anything particularly weird going on there. So really, that is not necessary at all. So if we take a look at the world mode stuff here, again, that's just, really this could just be passing down the world, and this is not necessary at all. So the sim center and the simulation bounds, I'm not even sure why we have both of those, because presumably the sim center always has to be the same as the sim bounds, right? You wouldn't be, like, what does that even do at this point, right? It just seems like something that's probably at this point a vestigial remain. So if we take a look at begin world change, and I look at the world position origin, right? Yeah, so that's all that's doing is it's just there to say, like, okay, this is the center point around which the simulation will occur. And this is the yeah. So really, we don't need to pass that world mode at all. All we need to do is have somebody pass in that sim center so we know where we are simulating. That combined with the rectangle would give us that. And this doesn't need to be here at all, right? I guess I should just verify that that's, yeah, just remember what that is, that this is the region we want to be simulating in that case. So I'll go ahead and grab that. Where is that? Right here. So when we are going to call begin sim, all we'll do is say, hey, we want to begin sim. We want to begin sim right there. And then when I come back up here and take a look at what we're doing in the other case, where we do begin sim with the sim bounds, again, that in this case, we now need some place. How are we doing our sim bounds here? We do work sim bounds. So all this should probably just come from the work structure. So we'd probably be wanting to do, oops. We'd probably want to be doing something like work sim center P, where that's something that would sort of be passed down. Okay. And so in this case, we'd say, what are the sim bounds? And what's the sim center? If I take a look at where we're actually doing that stuff, in fact, previously we were sort of doing this offset directly this way, which is not stable floating point wise. Like, we couldn't get arbitrarily large with that, right? That's the whole reason we have our concept of the separate center stuff. So at that point, we want to say, okay, let's do sim center P here. And we would want to do something where this actually gets baked in. So there is no offset here. The sim bounds are just the sim bounds as they are, right? And what we would want to do here is use the actual world coordinate system to just put the chunk, use the chunk offsets, right? So all we would want to do here is say, like, okay, we've got a world position, and like, again, we're doing this fairly arbitrarily because we're just testing. But here's our center point. And we want a chunk X, a chunk Y, and a chunk Z. Well, we wanted those relative, I guess, to the camera was previously how we were doing it, I believe. And so let's go ahead and say whatever that camera was. So we've got the world mode, camera P is where it'll be. And then we'll just say, like, okay, the chunk X and the chunk Y, we'll just offset these. And, you know, I don't know by how much, maybe -10 or something in each direction, maybe -15 chunks or something like this. Seems relatively straightforward. And yeah, there we go. And now we just want to multiply that by, yeah, by our loop. And now we've done the offset in a way that's, you know, floating point safe for however big we want to do it as well. Not that we care about that for this particular circumstance, but it's just good to know that that's what we're doing. Maybe these should be further away. I don't know. Who knows how far out they should be. If we want it to be roughly similar to what we were doing 100, 100 before. So, you know, if we want to take a look at what the default chunk size is, I feel like if it's 100, let's take a look here. Don't remember what where we actually allocate the world, but let's see. So if we're talking about our chunks being like 1.4 by 1.4, so if we wanted 100 of those, right? We're talking about, let's see, something like 70. So it'd be something like that. Okay. And that's really all there is to that. And now we can sort of finish up that cleanup, right? We also don't need to pass the camera P back in this result at all. It's got the sim region and the sim memory thing that passed back. We don't need these anymore, so that's nice. And then we can compile this. Let's see. Getting there. All right, so let's finish this up. When we do update and render entities, let's see, we're passing down the camera P there. So that camera P is really just, again, all that was just the sim center, the piece of the sim center information that we had there, which we don't really want, right? I mean, it was let's see here if I can put that back. It was really just the offset was pretty much all it was, I think. Let me just double check that that's true. Yeah. So I think that's really just, it's all it is the offset. And so when you're talking about update and render entities, you're just talking about whatever the offset is when you want to actually render. And so I feel like that's something that we would just pass down here. And that's just the camera offset. It doesn't need to get passed through in that weird kind of way. It was just like overcomplicating how that piece of the program was working. So what we should be able to do here is say, all right, we can do the simulation, we're going to do the rendering. Assuming that we do have the rendering, we just have like camera offset as a thing we pass down, and then camera offset can just be passed through directly, right? And I think that's pretty much all there is to that. I don't think there's anything else to it. All right, so let's keep working that through and see if we're right. Let's see here. Go. In simulate, again, we don't care about this because we're not rendering. Inside begin sim, same situation here. We just want to pass the world. Pass the world. Not sure why we're passing the camera P to check for joining players. That seems real weird. That seems really strange because this is the camera offset, which I don't think is what we actually wanted to pass here. That makes no sense whatsoever. Yeah. So that makes no sense whatsoever because that's like only moving when we move in between scenes. So I think that was probably a holdover from other stuff. I don't think we care about that at all. It's only the offset. So this, if we literally just passed the 0 point, that'd just get us the closest thing to the center of the simulation region, which is all we really care about there. So I don't even think we need that. In simulate, we do want to pass the camera offset, which is here. Particle systems want the exact same thing. Oops. Yeah. I think that's all there is. Don't quote me on that, but I think that's all there is. I would say I'm a little suspicious there. What just happened? That was a little odd. Everything appears to be working properly, but I am a little bit weirded out by the fact that the game is running faster for no reason. So that's... You never really want that to happen. I mean, hey, it's better than the game running slower for no reason. But yeah, that was a little surprising. I'm not sure exactly what happened there. That's not great. Should probably investigate that a little bit further in a second when I'm done cleaning this up. But, so, okay. Again, moving sort of slowly forwards here. So now when we look at what is happening with the world mode, we're really only talking about what's happening inside simulate. And inside simulate, we're just looking at passing some really basic stuff through, basically we're passing extraordinarily basic stuff from the world mode, and there's really no need for it to really be there anymore, I wouldn't think. Now, I don't know, I guess these don't need the world anymore. They don't need access to the world, which is what we want because it just does the pull in, pull out. So really all we need to do here is we need the brains need to get their entropy from somewhere, right? So we need to have some notion of what that entropy value should be for them to access randomness, essentially. And I'm not sure where the best place to get that from is, but I guess what I would say on that fact is because multiple people are accessing that entropy at the same time, potentially, I don't really know I don't know if we want to take steps to make that entropy be more friendly for multi-threading. Like, because it's just something that does a mathematical update, I don't know that it actually ever matters if two threads romp on it at the same time and replace the value that one or the other was trying to use. I don't know that that really ever matters, so it's probably fine that we just don't, as weird as that seems. But I don't know, right? So that's a little bit questionable. You know, another way to look at it would be that every thread should use a separate entropy stream so that you don't ever update, have two people updating the entropy at the same time. But again, I'm not really sure I can think of a real reason why you care about that. That may just be isolating something for no real reason. Yeah, that's a tough question. I can't think of any real reason why. So yeah. So this stuff doesn't actually need the world. The typical floor height here is one thing that we do need. Again, I'm not sure exactly how we want to handle that. Let me take a look again at what that's being used for. Let me put that back in temporarily so I can take a look. There we go. So yeah, so let's take a look. If we go out to the update and render entities, I want to look at what the typical floor height's being used for. I'm pretty sure it's just used for sorting people into which floor they're on. And that does seem to be the case. Yeah. So again, I'm not sure that we actually necessarily need that. I mean, we can do distance-based fog without that. There's a lot of different things we can do if we want that to, if we want that to be a thing. So I'm not sure. I'm not sure what we want to do there. Passing it down like we do here is obviously totally fine, and we could just make it so we pass it through simulate as well, because obviously anyone who's calling that needs to know the world structure as well, which means we could just pass it here directly. So I'm going to bubble it up for now, like just to see what happens. If we say typical floor height here, and this is not how I want to do it eventually, but I'm just going to do it this way temporarily. If I say typical floor height, and then I have the game entry get passed down, so that we're literally just passing the things we need specifically, rather than grabbing them out of stuff. If we end up like that, I want to take a look at what that would entail. When we call simulate here, obviously we could do world typical floor height. And then we need a way to get that entropy. And again, that would still require, I think, the world mode, right? Well, in here, same deal, right? And so we've bubbled it up one level, and so these are getting slightly better, but they're still, pretty. It's still pretty questionable at the higher level that those things would actually be necessary. If we take a look at what's going on here, we started to get this into a pretty respectable state in terms of what's going on. We've got our begin sim, our end sim, and our simulate step, and they're getting relatively clean. You will note, though, however, that execute brain still uses game state for stuff. It would be nice to get rid of the game state because passing the game state down here is not probably something we want to do. If you remember how that's working at the moment, you can see that the reason that that's there is because it needs to access the actual controller information that's happening when when the game gets input. I think there are ways we might want to do that that would not involve this, right? But as always, it's kind of a little bit iffy. So trying to think of where I want to go with it from here. I don't know how much time I've got left. I think I've got about 12, 12:15. I don't know how long I've got. So we started at 10:30, right? So I've got 12:15, 12:30. I've got till about 12:30, I think. Either that or 12:15. I can't quite remember, but let's say 12:30 for now. And I need more water. So I think what I might want to do is start hammering on the game state side of things. But then there's, again, I kind of think that game entropy thing is kind of a little bit of an open question, because I'm not sure, if that, because that's more of a world sim thing, I'm wondering if that belongs more in the actual world itself. I'm wondering if that's something that wants to belong in here potentially. It's really difficult for me to make a guess about that at the moment. But if you look at like the world mode stuff and you just look at the kinds of things that are in here, hard to say. Hard to say. What is time? Yeah. So yeah, looking at this sort of stuff, like we've got the particle effects in there. We've got the effects entropy that the particles are using. We've got the game entropy. Yeah, and so looking at this world mode, and by the way, as far as this to-do is concerned, having a separate camera struct is a good way to start that process if we did want to do that. Because if you play split screen, we duplicate and have two camera structs, right? Camera struct per player, that sort of thing. So I guess what I would say here is, yeah, like, I've got the world, I've got the camera in here. That makes sense. I've got the, standard room dimensions and stuff. That doesn't make sense. I feel like that wants to move into the world. You should be able to query the world and get those pieces of information based on your location. Particle cache does make perfect sense in here. I don't know that last use entity storage index should be there. That seems like that should definitely be on the world, because that is what you create entities with, right? So yeah, I feel like we've got some thinking to do about where these things go. The entropy is a good question because I don't really know where that would go. And I don't have a strong opinion about it, right? It seems like it's a property of a world itself, because it's something that, if you were going to save and restore, potentially you would save and restore the entropy. This game, it really doesn't matter, I don't think, because we're not trying to have any kind of a repeatable thing that goes on. But, in a game that was repeatable, if you were trying to do that, then you would clearly want that to be with the saved entity data, right? So it kind of seems like that's something that should be in the world proper, whereas effects entropy would be something that's more with the particle cache sort of stuff, right? So if I had to say, I would say it looked more, like, it feels like you'd want that in here, right? It feels like that's something that would be in here, right? Because the world is sort of this thing that stores information, and there's maybe a little bit of global information, and there's a bunch of spatial information. It kind of does seem like that would be the right thing. And I like this as entropy that does not affect the gameplay. Why is it called game entropy then? Oh, sorry. Well, I can't read it. That does affect the gameplay. All right, good. So yeah, let me take a look at where that's getting initialized. And so if we wanted to inside here, I guess we could say, when we actually create the world for the first time, we could initialize that like so, and off we would go. So then, world. every time we were talking about that game entropy, we would be talking about it off of the world struct, like so. Really, that's about it. And so then again, yeah, and with typical floor height, I think maybe I just want to start addressing that. Because it's bugging me, let's just do it. So standard room dimension and typical floor height, I want to start making those a little more systemic. So inside the world, like what I want to have happen here, basically, is I want you to be able to ask what room you're in. And then I want you to be able to, like, use the dimensions of that room at that time, if that makes sense. You could even imagine us allowing rooms of different heights to be stacked on top of each other. So I'm just trying to think about, like, if you're going to make this into a sort of a more robust system, what I want to be able to do is when I'm processing the world, I want to be able to get out notions of what rooms are that I can then use for these purposes that previously I was not, that I was doing sort of hacked, right? By just like saying, well, I kind of know how big a room is, so let's do this thing, right? So what I'd like to do is say, okay, how do we get that room concept in here? And to me, you know, one thing that I'm thinking of sort of here is, well, what if we just had a room be like an entity in the world, right? So there's just an entity called a room, and every time you have a room, you have one entity that sort of encompasses that room space, and that's what you actually use, right? And I feel like this has some attractiveness because to me that basically says, well, when we do our like begin sim or end sim, it means we could sort of, you know, all of the room entities that we see basically build up that knowledge of what the local area is, and then, you know, we're kind of done at that point, right? We now could freely create these rooms wherever, and when we exit the bounds of one of the rooms, whichever room we happen to be in, we would just then transition to pointing the camera so that it encompasses the other room. And I feel like that's just a more sane way to do it, you know, than constantly having these sort of notions of what's the height of a floor or something like that, which I don't really care about. You know, the code shouldn't really have to worry about things like that. I don't know why it would ever be something that's really all that necessary to know. So I'm just kind of curious if that could be the way that we would work it out. And like I said, I think I've got about 40 minutes, if that makes sense. So yeah, maybe I'll take a look at that. So how would that work if we were going to do that, right? If I take a look at the entity structs in here, you know, and I've kind of got entity types sitting around, and I've got, you know, whatever these things are here. Entity type stairwell, I don't know that we even have stairwells anymore. But if I did say that there was an entity type room, and that was just a thing that was going to be like a bounding box for room, you know, I could obviously create those. And maybe I start by just making some of those, right? So every time I add a standard room, which is the call that we have here, so we say like, okay, yeah, you know, add standard room. In addition to making all the entities that comprise the room, you know, maybe it also makes an entity for the room itself, right? So I don't know what I'm going to do exactly here, but I do like kind of a begin, end thing. Although to be honest, I don't know that end entity does anything anymore. Yeah, it doesn't really. So really what I want to do here is say, okay, let's go ahead and get our entity here. Entity, world mode. And end entity. And so all I really want to do here is say, okay, this entity will have a bounding box that is whatever the room's shape is, effectively, right? And I can make that be sort of a special case too if I want to. I can make it so that room entities in particular just have room bounds on them, and that's like their only property that they happen to have. And I should be able to construct an entity that therefore, you know, basically has exactly what we need. It would be centered about the center, and it would have extents that encompass the entire size of the room. So if we take a look at what that would entail, I guess what we'd want to do is say, well, all right, you know, here's the chunk position from tile position that we were using to create that. So if I was going to do that, I'd say it's just no offsets. That's the actual position, right? That's where it's going to be. And all I need to do now is actually give it a room, something the size of a room as its bounding box, right? And then that would be what it would need to have. So if I do begin entity, and I want to attach something here to it, I'm not sure exactly how I want to do that. Let's take a look at begin grounded entity here. You can see that it passed the collision volume. I guess I could just do that and pass the collision volume that's the size of a room. The thing is, I don't know that I really want it to be a collision volume. I may want it to just be something more straightforward than that. But for now, let's say we'll stick with what we've got. So we'll say we'll create a grounded entity, and we'll pass it room collision. Right? And room collision will just be something that's the size, because again, I'll just stick with what we're doing currently. I won't try to change too many things at once. And so here is our simple collision. So if I made one of these where I just want to, let's see here, make a simple grounded collision is presumably what I want. I don't know if any of these are actually what I want, to be honest. Because the grounded collision is actually centering its dimensions so that the center point, I think, is not where we want it to be, right? Because you can see this like dim z plus offset z nonsense, right? So if I actually did something here where I just said like, okay, make simple collision, then I could say, well, all right, I just want to make this to be centered around how rooms are actually centered. And I guess now that I think about it, I guess I don't know how we're really considering rooms being centered. Maybe grounded collision is really the more appropriate way for that, because if all the things are standing on that flat plane level, you know, maybe that's actually fine. So I don't know. We'll start with that, and I guess I'll see where it goes. So what I want to do here is say, well, how many, you know, I know what the standard room dimension is, right? We're saying it's 17 here. What's the tile dim is 1.4, right? So the standard room dimension, we're saying is 17 by 9. And the tile depth in meters, or rather the room dimension here is the typical floor height. There it is. So yeah, so if we take a look at that and just say that's what that is, and what if we just say, okay, now we're going to say we get rid of that standard room dimension. If we do that, I'm kind of interested to see like where we can go from there. I also want to know where people use that standard room dimension at the moment, so I know kind of what I'm going to have to be up against in terms of changing that over. So it looks like basically the sim bounds are being set to being the standard room dimension is how that's working. So we would just really want to we would want to sort of make that be a more fundamental concept, right, of just simulating a particular size. I guess we would maybe do a query for the room that we're at and then just look one room to each side and not actually, and then use those bounds without actually ever prescribing exactly how big that would be. All right, so for now, it doesn't necessarily matter, so I'll leave it in, but we could probably pull that in a second. Okay, so the next thing I need to be able to do here is I need to be able to see these things so that I know what's going on with those. So I think traversal is not what I want. I got to turn back on volume rendering. So let's take a look here. What is the question? We have entity transform and render group. Let's see. Can't actually see all the stuff that's there. There we go. So push rect outline is expecting a render group, which we pass. It's expecting an entity transform, which we also pass. It's expecting a rectangle, either a V3, which in this case is what we're passing it, a V3 and a dim2 and then a V4. So it's just the real, it's this last floating point value here that's the part that we're not passing. So let's take a look at what we want to pass for that. So that's just the thickness, it looks like. So we must be passing, because it looks like that should have worked, right? There's the group, the object transform, there's the offset, there's the dimension, there's the color, and the thickness should have been auto-filled in. So I'm not sure. Let's see what it thinks. Ah, I see. That's just needs to be an address of. That's it. All right. So if we have our little transforms drawn around us here, I'm gonna pull out so we can see. Yeah. So what I want to be able to do here eventually, right, is I want to be able to get to the point where I can see that the room bounds are actually, that there's an actual bound around the room that we're in, right? I want to be able to see that. And I'm not sure that we then would really need the yellow or white bounds here that we were drawing before, because those are sort of hacked bounds that we're just drawing where we thought the room boundaries were and so on. So let me take a quick look at that as well. That's inside world mode here, where we just kind of draw. Here we go, where we've got like, okay, push rect outline, right? Where we're drawing that stuff in here. We draw, what do we draw? We're drawing the screen bounds, the simulation bounds, and the sim region bounds. I don't know that those two are really all that different. I guess we previously did have them be different, but nowadays they're kind of not. All right, so I guess I'm not sure what we even care about the screen bounds anymore for. I guess it's just because that's what we were using for simulation previously. But yeah, it's really not even something that we really use anymore, right? So it's a handy thing to draw just so we know that we're still computing it properly, but again, yeah, we're not really using it for much. Okay, so if we want to draw now if we want to put in entities that are the shape of rooms, what we want to be able to do is sort of see, we want to be able to see clearly what those outlines are. So what I might do here is I might go ahead and say, let's take out the trees for a moment. Maybe, or we could just maybe turn off entity drawing for a second so that we'll actually be able to see a little bit more clearly what's going on if I were to put in an outline there. If I wanted to do that, all I would have to do here is just stop any usage of the actual pieces. And so here we can see more sort of more abstractly what's going on, right? And there we go. So what I want to do, yeah, again, and maybe I'll have to turn off even a little bit more of the stuff that we're drawing here just to make sure we can still see it. Because it's going to roughly fit exactly that bound. So I might have to turn off a couple more things in order to see it. But so let's go ahead and temporarily turn these off as well. And, well, I'm still getting the white region there, so I actually want that, I think. Okay. So here we've got just rectangles drawing, and I guess the particle systems are still there, the little test particles. I do wonder why our particles, we sort of turned off some of the updating here, right? When did that happen? Our particles no longer, we turned off a bunch of stuff for our particles, but I don't remember what we turned off exactly. I think we turned off like the upward velocity of them, perhaps? I can't quite remember. Here's the actual simulate the particle forward in time if it was flame displacement. So it looks like we were just trying to isolate what was happening. So we probably just did that, right? There we go. Not sure why we wanted to do that right now, but I was just like, I forgot we never turned our particle like sort of push back on. Who knows why. All right, anyway. Point being, I want to now be able to see these rooms so that I can verify that they're getting created in the right place. So every time we do add standard room, what I want to do is figure out a way that I can add an entity here, and that entity will sort of encompass the shape that the room actually is. So all I really need to do, I think, there is set it, the type of the room to be an entity, if that makes sense. Where is that actually set, of course, is the other thing. Oh, so did we actually eliminate the entity types entirely? So I think we would actually just need to have this be sort of a separate concept if that's the case. Like, are these gone now? Yeah. So we need some way of knowing that this is a room. Well, I guess we don't really even need a way of knowing it's a room. We just need, at the moment, we just need it to actually be created there, and I need to actually be able to see that it's sitting there. So in theory, that should be creating it, but I'm not 100% sure that I can actually see it now. Of course, again, it may be that it's just hidden behind those things, so I kind of need to be able to turn off even more to be able to be sure that I can see it. So if I kind of go into entity and also turn off rendering traversables, maybe that would give me enough. I'm not sure that it would, though. Well, let's see. Right, because we can't really even still tell, you know, it'd be really hard to see whether there's entity kind of going on behind there if it was just between, it would just be getting overdrawn potentially. So I need some way of being able to peek back behind there. And I'm not sure exactly how I'm going to do that. You know, it looks like it's there, right? Because it looks like that's the boundary. And I have it selected at the moment, but I don't actually know, right? So I think that is actually getting created in the right place, but I would like a better way of doing that. I suppose one way to do that would just be to turn off the trees entirely. Let's take a look. So inside add standard room, when I'm actually adding the walls, add wall. I'm just gonna not. Okay. So yeah, so it is there. Now I can actually see it. And if I go ahead and move out, let's see here. So yeah, it looks like that actually does work just fine. And those rooms are now being created, so I can actually look and verify that that's actually true. However, like I was saying before, okay, so we do still have a problem now, which is that we don't really have, however, any concept, though, that rooms are special in that way. And so I'm not sure what we want to do about that, right? So let's take a minute and think about that. I can turn off the volume stuff here. One way to do that is to just, and in fact, I guess now that I think about this, kind of interesting. One way to do that would be to, you know, sort of use brains for this purpose. So we could basically say, like, okay, walls are all participating in a particular brain type, so every time you get a wall, it gets added into a brain slot. I'm not sure I remember. In fact, I don't think we do. That would do some interesting things with brains. It would create like a brain limit. I guess basically what I'm saying is here, so we have brain types, right? And brain types are just the things that's like which AI controller you want on your thing. And so, you know, you could imagine reusing that effectively for doing the gather for rooms, right? It's sort of like a brain for the camera, if that makes sense. So if, for example, I said, oh, there was, you know, a room brain, and so anything that was a room got added to the room brain. In theory, that would work. The thing that it creates is it creates a dependency here where you're basically saying, like, okay, now the maximum number of rooms that you can have in a simulation region is proportional to the maximum number of slots in a brain, which I don't know is really something you want to do, right? And so I'm a little reticent to go that route, even though it is kind of convenient and nice. So it kind of, again, it feels a little bit like that it wants to be more of a first-class citizen than that. I don't really know, right? It feels like it wants to be something where the world has more knowledge of what a room is and doesn't have to come at it quite so sideways. And so I do worry a little bit about making it that in line with how everything else works. It's got a nice attraction to it in the terms of, well, it just reuses stuff that we already have, but I don't necessarily like some of the implications there. So I'm not really sure. I find this to be a really tricky one. I'm not sure how I want to do that. I think it makes a lot of sense for the rooms to be stored as entities. I just don't know if it makes sense to overload the brain concept for them. So I'm kind of thinking that maybe more what I would prefer there is like the simulation region, itself keeps a separate list of rooms. So anytime it is going to unpack a room, it is going to record that, and it's a separate marker in the entity thing that says this is a room. So let's take a look at what would happen if I did that. I'm just curious to know. Because let's take a look at all the people who have to actually deal with this as a thing. So, when we're doing update and render entities here, we sort of do this stuff with the, with the typical floor height. And that's used for computing sort of a like per level fogging effect that goes on there. That won't have to happen anymore with a Z buffer, right? Because once we have a Z buffer, we'll be able to just have actual fog that goes down with a in a regular kind of Z fashion. And so I'm not sure that that's really all that necessary. So I don't know that anyone in here is actually ever going to care again about that particular piece of information, right? We don't need any. Look, we were going through extraordinary lengths here to try and sort entities into floors properly, and then have those floors, get alphaed separately and all these other sorts of things. But we don't really need to do any of that anymore. We can now just do 2 passes with the Z buffer and be done, right? So it's definitely the kind of thing where I'm like, oh, all right, like, we can foist some of this over to the GPU as something that it has to deal with, and then we don't have to really deal with it much at all. So, again, floors in that sense aren't particularly necessary in any way either. So it feels like it's really mostly about the camera is the reason that we actually care, and the only person who'd really be caring about it is when we go to do that camera update. So it's kind of like we almost don't need to know at all in a lot of cases. And that does seem pretty likely. So taking a look at update camera for entity movement here, like, let's imagine what would happen. Suppose that we just brute forced it, right? And that we weren't even doing anything particularly interesting. Suppose that we just did a for I loop here and said, okay, let's look at all of the room entities that are in this simulation region. Because you can look at what's happening here, right? We're looking to see if you're outside of the room, that you were last in. So you can see here we're saying is the entity Y outside of whatever that room apron is, and when it's outside of that, that's when we start that transition, right? I feel like we could just do looping over the entities and find the 2 closest rooms to wherever the entity is, and then just do the interpolation that way, right? And this would be the only thing that ever actually cared about that. And that's pretty compelling to me, because then we would literally not care ever about this. We wouldn't have to keep them in the brain at all. We could still use the brain type for this purpose if we wanted to, but we wouldn't ever have to actually add them to the brain set. And we could also, if we wanted to, have an out-of-band place that we stored those. So yeah, I mean, yeah, I guess I just say, like, let's imagine what this would look like. So imagine we said there was a type brain for room. And we say here, like, hey, by the way, these are special types which are used to mark special entities. So let's say we didn't have a particular brain type, and that was brain type room. But when we begin the world change, and we come through and we're processing the entities, instead of actually creating a brain for this brain, we actually do a test first to see whether or not the brain type, well, actually, the brain value can just be 0, and the brain type will be set to room. And that'll just work, because it won't try to unpack the brain if the value is 0, right? So that's perfect. That's exactly what we want. So that's kind of cool, right? So that means we can just use this to mark people, and it's essentially a free entity typing system if we need that for certain special types. I guess I'll put this down here. And that way I can mark those, but I can still leave the brain slot as 0. So for example, in here, when I actually make one of these, in add standard room, I can just go ahead and say, well, when I set this entity, I'll just go ahead and set the brain slot. I believe that's just this stuff down here. You can see how it's normally done, right? So if we take a look at this, you can see we do brain slot, and I don't actually want any of that stuff to be happening, right? So brain slot, I guess I can just leave it as 0. Brain ID, see here. Want someone who's going to set that. How were we setting that before? ID. Like the Monstars use them, right? Yeah, it just uses add brain. Yeah. So that actually works perfectly, because then when we're doing like, okay, the brain ID, we could just be like something like special brain ID, and then we can just say like, okay, let's say what we want the specific type to be. So let's make that like brain type room. And when we do, yeah, you can see we've got no brain here, right? And when we do that, I could say special brain. And I feel like when we do add brain, that's just right. Those brains, where is it actually getting that type from? When it does, oh, so the brain slot, right? So I don't really want the brain ID. I want the brain slot is the one I actually want. So this is really a special brain slot is what we're actually looking for, right? Yeah. And so when we're talking about the brain slots there, what I really want to do is just say like, okay, I want a way to get a special brain slot back, which is like special brain slot, that, and I just say brain type, if that makes sense. And it initializes that. Like so. And so that means even the index would be fair game for us. We could set the index to something here if we cared about it. We don't really care about it in this case because we don't have any actual information to store there. But you could actually store additional information there if you wanted to. We just don't happen to want to. So if I do that, brain type choose, okay? That's fine. If I do that, now I shouldn't break the brain system at all because it shouldn't even be getting used. It's just kind of stored there as a piece of information that we can use as sort of a demarcation, right? And so when I take a look at that, and I guess there's really not necessarily, since we are talking about doing entity stuff sparse, we could decide to move that out into a separate variable if we want to later, but for now we'll just use it that way. Inside the sim region, what I can do is say like, oh, okay, when I'm unpacking these guys, I can say if the destination's brain slot type is, one of these special types that I care about, I can do something different here, right? I can say, when I get one of these, do something with it here. So if I wanted to keep a separate list of rooms, I could. I think I'm just going to brute force it at the moment. I don't know that that's a great idea, but I think I'm going to, just so I don't have to put a constraint on the number of these that there are at the moment. But we may want to, we may not want to do that for all time, right? So if I take a look at, where's my sim region? When I'm updating the camera here for entity movement, I guess what I'm saying is in here we could just say like, okay, let's loop over the entities. Maybe we keep a separate list of those during unpack so we can loop through the rooms separate, as a separate thing. Probably something we'd want to do. But what I can do here is say like, all right, when I loop through all of these, let's just get the room, whatever the room the player happens to be in at that time. Let's just get that. Let's just figure out what that is and call it a day, right? So if I loop through here and say like, okay, here's the entities. I'm going to need the sim region here. And all I want to do is say, well, okay, for all the entities that we had, I'm just going to look and see if I've got any room entities. And if I do, I guess I just want to look to see, is the center of the sim region inside that room? Because that would be the determiner of which room I was technically in at the time, I believe. Right? That's sort of the determining factor there, right? And I guess I don't really remember exactly how we were eventually moving the camera per se. I think it's just once we get past the apron for setting the new camera P, right? So yeah, you can see we only really do it if we get past that room delta. All right. So the room delta here, I guess we have it set to just be literally twice what the, or rather what that actually, I think, multiplies out to be. Let me just double check that that's true. So if 1.4 times 17, 24, yeah, so it's a little bit bigger than the current, the room delta is just a little bit off from the actual room size. So if we want to here, we want to just say, all right, let's suppose we were going to compute all of these things from the actual information we get back about the room itself. And so we want all of this information, but we want to get it dynamically. So if we take a look at that, all of this stuff is basically dependent information. Again, I don't think we actually want to do this after we're done. I want to make the camera move a little bit smarter than how it's doing right now. But just for the moment, this room delta piece of information here is really just, it's just the size of the room, right? So if we search through here and found a room that was included the simulation center, right? And remember, I know the simulation center because it's 0, 0, 0, right? It's always the origin of the simulation. We always, all the things have been mapped into that space. So if I was to loop over the collision region of this thing, and really I could just even probably use a point query test here, because we've got, say, entity overlaps rectangle, right? and you can kind of see where we pass collision volume in a rectangle, and we look to see whether those points intersect. So this is in rectangle function is exactly what we need for that purpose, right? And so that's really all I'm talking about here. So what I would do is I'd loop through all these entities and say, for every entity, if it happens to be a room type, is 0 in it, right? If point entity contains point, right? And then I just pass the center of the simulation region, which is always 0, 0, 0. I pass the entity in question. And once I've figured out whether it contains that point, then I'm done. Now I know the room that we're actually in, right? And so I could say room in room 0. In fact, I can move this down here now, and I could just say like, okay, in room equals test entity. Once I know the room that I'm in, then I just need to use the bounds of that entity to figure that out. And in fact, I could, if I want to, make that be a property of the actual collision test. It could return which of the rectangles it was actually in as well, and I could just save that information. Because if you take a look and, let's see, is in a rectangle. Let's see, entity. Let's see. So inside here, I believe we typically have to, well, okay. So we do have the total volume. So I guess what we can do is just always use the total volume. All right. That's fair. So I guess we could just always say, like, all right, so the room delta itself is just the total volume for this entity, right? So we just say, whatever the in-room total volume is, that's going to be whatever the room delta is. Now, mind you, at this point, we also have the problem of, well, we may not have found one. And if we haven't found one, we probably just want to leave the camera where it is, right? We may also want to just do an assertion on that. We'll see how it goes, because probably there isn't a time when that should really be happening. So when we do this, and we loop through entities, we see if we find one. I guess I can say entity overlaps rectangle. I suppose we could actually just reuse this function if we wanted to. I don't know that I really want to, but if we did, it would just look like this. I have here a thing which says, here is a volume. I want to know if an entity overlaps it, so I give it the, I can just give it the volume that's a 0, 0, 0 volume. It's like the null rectangle, right? It's just whatever the nothingness is right at the center of the simulation region. If the entity region encompasses that, then that's technically there, right? Again, not really necessary, but it's just to reuse this function at the moment, since, no reason not to while we're starting to get things going. So total volume for entities, I guess I don't know. It has an offset P and a dimension. I'm kind of interested to double check that here. So here's entity overlaps rectangle, and we're checking to see if something is inside a rectangle. You can see that it uses the offset P there, right? So if I want to do the find the room delta, I just need the size of this thing. So all I care about really here is the dimension for the time being. And so this now needs the sim region in order to do that update step. Looks like this comes first. All right. So I think that's about it. And like now we're going to have to actually debug this, but I'll probably save that for next stream, right? Because right here we should be going outside, and presumably that's not getting picked up properly. Let me double check to see where we're at in terms of that. There we go. Yeah, and you can see it's not actually able to find one. So let's just do a quick to-do. This will be a really simple debug, but we'll save it for next time because I'm going to want to kind of go further into this as well at that point. And let's go ahead and go to the Q&A. Okay, so this is a three-part question. One, do you ever work on large multi-million lines of code bases like Chrome, GCC, Unreal, etc.? The full build dev process you've been using works for small projects, but how do you scale? So I guess I would say that that's sort of a that is not something I want to do kind of a question, right? So it's like, in my mind, if you have a code base that you cannot compile in 10, 20 seconds, then I probably wouldn't work on that code base, right? So if you took something like Chrome or GCC or Unreal or whatever, I would just point out lots of stuff about that. Right? So first of all, if you have something that for some reason actually does have as much complexity as would require multiple millions of lines of code, which by the way, none of those three projects do. Like I would not consider Chrome or GCC or Unreal to necessitate that many lines of code. But let's say you do have something which legitimately the problem with it is that it necessitates that many lines of code, not just that there are more lines of code than there should be in the project, which is the actual problem in a lot of those cases, right? For example, GCC, there are compilers that are incredibly tiny. So the way I would write a compiler is I'd write one that was much, much smaller than GCC. I consider the size of the code to be a actual problem and small code to be a feature. So I don't consider it outside the scope of an answer to say that's you've made a misstep if you've gotten into that situation, right? But let's say you did get into that situation and maybe you're coming on and you've just been handed GCC and you have to use it, right? Then like the very first thing I would do is break it up into modular pieces that I can build and work on separately, right? Because if I can't rebuild the whole thing in a reasonable amount of time, that's a huge, huge, huge problem. I would consider that the most important problem to solve on any project immediately is if you can't build the whole thing in a reasonable amount of time. Because it really severely affects the ability of programmers to make large-scale changes to the architecture. They just can't do it. They won't be able to do it if it takes 30 minutes for them to see what a change is like that touches a lot of things. And so I just don't feel like that's a way to program that is sustainable. So that's what I'd say. So I would actually turn around and say, if I can't build a project with the Unity build, basically, right, with the ability to just like build it all as one build and go, if that's taking 30 seconds, a minute, 10 minutes, heaven forfend it's a half an hour, then that's problem number one. Like that is the thing I will be working on until that's not true anymore. I would not even dream of touching any other feature of the code base until I solved that problem. It would be problem number one. So yeah. Let's see. So part two, why is past video archiving disabled? Just because like I did not like the fact that those videos were being used because and capped basically. Like the on-stream like discussion stuff that's not part of the official recording is not supposed to be permanent. You know, it's not supposed to be a thing that gets archived. And so I had the Twitch replay stuff enabled because, you know, people had been using it that way, but then, you know, it's gotten to the point where people were like saving those or clipping them out or doing stuff like that, and that's not the intention of them. So the fact that I couldn't really keep that from happening means that I just turned it off. Am I in a closet? The back wall looks really close. No, I just happen to be close to the back wall. Sylvestos 2, I don't know if unrelated questions are allowed, but how do you stay so focused on your programming and are so efficient? I guess I don't know. I don't think I'm particularly efficient. I certainly don't feel particularly efficient on stream because talking a lot about stuff kind of slows things down too. I guess I would say, you know, don't allow yourself to do other things other than work on your code on your computer is a really good way to do that, right? Like staying focused on things is kind of about not allowing yourself to go do other things while you're ostensibly working on programming. And you know, that's actually something that, amusingly enough, doing something on a stream actually helps with a little bit, because if everyone's watching you program, you're not going to go like read the internet or something, right? Or at least hopefully not. So that's one thing that's kind of helpful. At work, normally I just don't. My computer isn't plugged into the internet, and I don't install anything on it. So my computer is literally nothing other than a compiler, the debugger, and my code base, and that's it. It's not plugged in the internet. It's not plugged into anything other than the backup server, right? And that's just because, yeah, like there's always a temptation to go do something else, and so I find the easiest way to not do something else is just not have the ability to do something else. And you know, that's what it was like growing up, because there was no internet, you know. And so, you know, it just tends to be about trying to maintain good habits. And I think anyone can learn to focus and stay focused. Sometimes it requires paying attention to things that you wouldn't normally pay attention to. Like, for example, making sure that things that you would never necessarily think of can be important. Like, for example, what you eat, like what you eat in the morning. You know, maybe you work better on a cup of coffee and, you know, some bacon or something like this. And how much you eat is important. You know, what your blood sugar is, what your mental state is, that sort of stuff is affected by these sorts of things. Getting regular exercise, stuff like that. Just, you know, maintaining a healthy sort of environment for your brain in terms of both what's on your computer, what you're doing with the computer, but also like physically. Also helps a lot, right? If you're feeling tired all the time, or you're having a sugar crash or whatever, those are bad things that make it hard to stay focused too. I think the speedup is due to wrong offsets of the simulation regions for the multi-threaded tasks. Use the tile size for your calc, not the chunk room size. That could be true, yeah. Like if those are not, well, I don't really know. Yeah, but yeah, I agree with that because I'm not particularly careful about what was going on there since those are made up points. Now that you intend to use 3D, will the code support software rendering? Yeah, I think so. We may not support all the features, but I think we'll probably still keep that path updated. Is the career advice episode uploaded anywhere? I'm having trouble finding it. It'll be up. All 3 parts will be up shortly as a blog post, and they'll also be on the they'll still be on YouTube, but they'll be in a blog post too. So all 3 are kept together and with links. I'll be copying and pasting links from the things people wrote in. You said you want to remove the notion of rooms layers from the drawing routine, but don't you still need it for fading in the room above you? I don't believe so, because like I said, since we're going to move to 3D, we'll now be able to use the standard tricks we would have used there, which is to say all we have to do is just go like, oh, okay, there's a certain height above the camera. When we set the camera in this update for camera routine, we know how high the ceiling of that room is, and that'll just be a property of the camera that we then use with the Z buffer to do 2 passes. 1 pass for everything in front of that Z level, and 1 pass for everything before it into 2 separate buffers, right? So we now kind of have the ability to do a bunch of sassier things. Let's see. You said that 20 seconds to build is a reasonable amount of time. Well, I wouldn't necessarily say it's a reasonable amount of time. I would say that it isn't necessarily the amount of it isn't the amount of time where I would automatically think it's a problem, right? So if it takes 20 seconds to rebuild the entire project, I wouldn't necessarily stop what I was doing and go focus on that as my primary problem, right? I like to keep things much faster than that, but I can live with it in that range. Somewhere around a minute, it becomes obviously the biggest problem you have, right? And where exactly that breaking point is hard to quantify. The faster the build, the better, pretty much down to about somewhere under a second. So, a build that takes 1 second is better than a build that takes 2 seconds, right? But at some point, a build that takes 50 milliseconds is not better than a build that takes 100 milliseconds, for the most part. At least not in any way that I've ever been able to determine. So yeah, I don't really know how to quantify those things in any way other than to say that there's an obvious breaking point somewhere. And I mean, 30 minutes is obviously a disaster, which is not a straw man. There's lots of builds that take over 30 minutes to rebuild the whole code base, and that's just a huge problem, right? All right, last questions. Off topic, will Handmade Con 2016 video on demand be on YouTube soon? It's out of my hands right now. Folks volunteered to edit the videos, and they are editing the videos to combine the camera footage, because it's just a bunch of raw camera footages. When they're done, they will be posted, but I don't know when that is. Godling72, how long did the witness take to build? I don't remember, but quite fast by comparison to most projects that I kind of come onto that I wasn't in charge of. I want to say that you could build the whole project in 30 seconds maybe on a good machine. So, was it as fast as I would like projects to be built? No. Was it well within tolerable range? Yes. On the witness, I would say the thing that I had much more trouble with was startup time of the game. And I think that was partly because I didn't really know enough about how to do some of the art workflow things. So I usually ended up getting around that by having a test level thing that I kind of built that I could load into and not have to go through whatever was happening. But I think the way that the witness was structured, there was several parts that I wasn't really very knowledgeable about. And so my experiences with it are not really representative of what it would be like if you were someone who's normally on the team. But my recollection of building the witness was that it was, well within the speed of rebuild that would not be a problem at all. And again, that's because John cares about this sort of thing, right? I don't think he would be super psyched if his game took. Someone's saying 5 to 10 minutes to build. Like, no, it's nothing like that. The Witness was very fast to build by any modern game standards. Like I said, a lot of them are just incredibly slow. If you can build the entire Witness engine and game in probably, I'm imagining the amount of time it would take you to build, 10 files of the Unreal Engine or something like this. It was very sensibly architected for that. Yeah. All right, I'll go ahead and wrap it up. Okay, thanks everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, so you can play around with it and learn from sort of stuff we're doing on stream. We also have a forum site if you want to ask questions, and a Patreon if you want to support the video series. We have a schedule bot that tweets the schedule at you, and I'm going to be upgrading that soon to correctly handle weekend streams a little bit better. Right now I kind of have to do it manually because it was originally built for weekday streams. And then we also have an episode guide you can go to if you want to catch up on stuff that happened before. That's about it. I will be back next week for more programming where we'll try to finish up that room-based stuff and maybe create some different sized rooms in the game so we can verify that that's actually working properly. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.